All right, here we go. So one of the first things we want to talk about is actually how to identify a linear equation. In the red, you see that the equation is ax plus by equals c. Now, you won't always see it that way. The a, b, and c will be numbers, more than likely in your case. But we want to give them kind of a general look. They could be anything. Now, the x and y, little bug, the x and y are actually always going to be there. Now, they could be other variables, but for right now, we're going to focus on x and y. So here's how you identify a linear equation. How do you know it's going to be a straight line is the question we're going to answer. First bullet point, the exponent of each variable is 1. So basically, there's not anything like an x squared, y cubed, anything like that. They're all x to the first, y to the first. Secondly, the variables are added or subtracted. Notice you don't see like ax, y. They're not touching. They're not dividing. So as long as your variables are separated, then you're good. And you only have one x and you only have one y variable. That's what we want to look for. Third, a or b can equal 0. So if that was the case, it would look something like ax equals c. So if the b were 0, then that's what it would look like. And vice versa. So that happens occasionally. Think of this as being like 4x equals 10. Could you solve that for x? But then again, we might need to simplify that down. So next, the a value must be greater than 0. So what they're saying, for this to kind of link itself between the linear equation format and the standard form format, we need to have our x term in the front, and it's got to be positive. So if you were to have, let me write this down real fast. Well, hang on a second. Let me erase part of this. Okay, here we go. So what I'm trying to write here is we have negative 2x equals 3 minus y. That's a really rough y, sorry. Negative 2x is, first of all, my y and my x are not on the same side. So what I could do is I could move the negative 2x over to the right side and make it positive 2x. And what can I do with my 3? If you're saying subtract the 3 to the left side, you're exactly right. So what that would look like is this. It would be negative 3 equals 2x minus y. And that would look like ax plus by equals c. It would just be turned around facing the other way, which is totally fine as long as your x is positive. So make sure that you hone in on that portion right here, the fourth bullet point. Next, besides x and y, other commonly used variables are m and n, a and b, r and s. Guys, we can use anything out there, any pairing. They're just showing you a few of the common ones. And then this one, second from last, there are no radicals in the equation. So no square roots, just like there's no squares or cubes, there's no square roots or cube roots, or anything more. So make sure you notice that. That's a pretty good indicator that you don't have a straight line. And then every linear equation graphs as a line. So the word line pops up, you see in red, right there. It's a straight line, okay? So let's go look at some examples and some more details. Okay, so here's some examples of some linear equations. I got you cut off a little bit with my face over here. The first example, 2x plus 7y equals 8. It's already in the form. And notice that 2, 7, and 8, you cannot reduce that. So one of the things that we're going to talk about with standard form is that it has to be fully simplified or fully reduced. So make sure you can divide by the 2 in all places if you want to simplify. In this case, 7 is a prime number. We can't reduce that. But that's great. X and y on the same side. 2x is positive. That's good. Next, 6y equals 3 minus x. So what they said is that they can rewrite with both variables on the left side. So if you're saying that they could add the x over to the left side, then you're exactly right. The x would become positive and everything's reduced. So you see the answer in red on the right. X equals 1. So ax plus by equals c. So what they say is that the b is 0, which is totally fine. And you see how they've written it in red, x plus 0y equals 1. So just be aware of those kind of funny looking equations. Fourthly, negative 2a plus b equals 5. Well, now the a has been replaced by the x. Excuse me, the x has been replaced by the a. What could you do to get rid of that negative 2? But just the negative sign in general. So think about that. And what they say is multiply both sides of the equation by negative 1. Another trick in the book is if you need to change the sign of a term, you can change the sign of every term. So the negative 2a becomes positive, the b becomes negative, and the 5 becomes negative. Now remember, the only thing that you have to have positive is that front term, the 2a. Alright? So that's what we want to change. And now this last one looks a little different, and you're like, you know, this definitely can't be changed into standard form of a linear equation. It sure can. Just multiply both sides by 3, get rid of your fraction, and look at what you end up with. 4x minus y on the left, 4 is positive, that's good. And negative 21 on the right, we don't care if that's positive or negative, and it works out. So these right here are examples that are not in standard form, and they would be examples of nonlinear equations. So the first one, you see there's a squared. That's pretty obvious. Can't have a straight line with that. The second one, there's a square root sign, a radical. The third one, you have x and y touching. So you only still have two variables, but if they're touching like that, showing multiplication, we're not going to get a straight line. And then finally, the last one, it's similar to the touching multiplication. We have s divided by r. We can't divide either. All right, so all four of these are good examples. You cannot change these to be straight lines. They are what they are. They're going to have some curves in them. Okay? So now that you've seen a lot of the linear equations and examples of nonlinear equations, we'll still talk more about that. But those are the good hints on how to recognize if you have a straight line or not. And then standard form, you may have heard of in Algebra 1. It's one of the three forms that we'll write equations in. It's important too because it's got its specific details that we have to follow. Now, when you have standard form, probably the easiest method of graphing is using x and y intercepts to graph, and we'll see that in a second on an example. So go ahead and get this down in your notes. X and y intercepts, what are they? How do you get them? So x-intercept is the point where a line crosses the x-axis. It's where it intercepts the x-axis. So this is the one going horizontal, left to right, and wherever your graph crosses, that is your x-intercept. Now the general form of the x-intercept on this point right here is x0. Oh, sorry. So x0 is the format for your x-intercept. You always have a 0 for the y value because it's not high or it's low. It's just right there on the axis. Secondly, the y-intercept is the point where a line crosses the y-axis. You see this more often in mx plus b form. The b is your y-intercept. We don't have the same thing for the x-intercept, but there's ways we can get it. So the general form of the y-intercept is 0, y. So guys, the form actually is identifying the x or it's identifying the y. You just have to know what place it's in. So that's maybe a hint. Let's look at the next slide and show some examples. Before we do the example, what I want you to write down basically is this. If you want to find the x-intercept, I want you to plug in 0 for y. So find the y value and put 0 in for it as a substitution method and solve it for x. In the other direction, I want you to also plug in 0 for x and solve it for y. Now this means you're going to have to do two different problems, but they don't take very long because when you plug 0 in, things kind of just disappear and cancel out quickly because 0 has that effect on an equation. So understand that you have to do it twice, once for the x-intercept and once for the y-intercept. So for our first example on x and y-intercepts, so you have the equation x equals 4y minus 5. It's up here at the top. I'll underline that. And I want to go straight into my problem. I want to figure out what my intercepts are. So my x-intercept, I'm going to plug in y equals 0. So you see x equals 4y minus 5. I write my problem down. I put in 0 right here for the y. And I solve it. 4 times 0 is 0. 0 minus 5 is negative 5. So therefore, in the end, make sure you write this down. Don't just think x equals negative 5 is your answer. You have to have the ordered pair. Points will be taken off on quizzes and tests. So negative 5 comma 0 is the x-intercept. So you go over here to the y-intercept. Plug in x equals 0. So you see it's plugged in right here. And you have to add your 5 across to the left. So you get 5 equals 4y. And then divide by 4. So you get 5 over 4. We cannot divide that nicely, so just leave it as a fraction. And you get 0, 5/4 as the y-intercept. Okay? Now I want to give you one final example to try. I want you to recognize one thing first. 6x minus 3y equals negative 18. Is this in standard form? The 6x is positive, but if you're thinking that maybe you could have divided by 3 in every case, then you're exactly right. So this could have been trimmed down a little bit more. But for the sheer fact that it's an equation and we want to solve it for its x and y-intercepts, you could just do that. So read through the x-intercept and the y-intercept, get down to the bottom, and you'll see the answer. I'm going to leave this one up to you. If you have any questions in class, you can come and ask. So go through this. You can pause the video and you can go through this problem right here. Now I wanted to show you a couple of special cases. So when you find the x and y intercepts of like x equals a number, here in this case 3, understand that when you graph x equals 3, it's only 3 on the x value. So as you see down here in the bottom right on the graph, it's a vertical line. So on the x-intercept, when you plug in y equals 0, you can't. So 3, 0 is the x-intercept because x equals 3. When you go to the y side and you plug in 0 for x, it doesn't make any sense. But when you think about your graph, there can't be a y-intercept. Alright, so make sure you understand that part. Now, the same thing as x equals 3, now we have y equals negative 2. So when you plug in 0 for y, trying to get the x-intercept, it's not going to work. So you have a horizontal line. When y equals negative 2, think of it, the only y value you can have is negative 2. So you go down 2, and you just draw a straight line across. So think of the x equals as going up and down, and the y equals going left and right. They do the opposite of what their axes are, okay? So maybe take a hint, read this slide over again. So here we are, everybody. We're at the end of the lesson, and say hi to little Blake. She's got the sun in her eyes, eating her Cheerios. But just wanted to make sure that by the end of this lesson, I wanted you to get out of the lesson standard form, how to recognize a linear equation, follow all those rules. There's a lot of things that you need to look for that might open your eyes to seeing if it is linear or not by not even having to graph it. Yeah, it's not that hard, is it? It might be, though. You need to kind of write these rules down, write examples down, and see if you can spot some of those moments in your homework problems, in classwork and whatnot. We'll practice this. So if you have any questions about x and y intercepts, standard form, or how to find a linear equation, ask in class, come by early, and I hope you have a great day. And remember to always flip and don't fly.